Hello everybody. Today I can solve radical equations by squaring both sides. That's the main step in solving radical equations, but there's a couple more steps to it than that. Basically the steps are written out here. We're going to isolate the radical, make sure the radical is by itself on one side of the equation. Then we're going to square both sides. Once we do that, we're going to solve the equation, and we must check. Not check like, let's make sure I didn't make a mistake, but you may have done everything correctly, and one of the answers may not work out, so you need to check. So, let's start with number 1. In fact, let's start with number 2. My first step is to isolate the radical. Is the radical isolated? Is it alone on one side of the equation? No. So my first step here would be to isolate the radical. I see a plus 2, so I'm going to subtract 2 from both sides. Now, I'm not isolated yet. I have to get rid of the 5, so I'm going to divide by 5. When you're isolating, you always add or subtract first, divide last. Now that I'm isolated, to get rid of the radical, I'm going to change colors for the next step. I'm going to square both sides, because a square and a radical cancel out. The square and the radical cancel. I'm left with 4x minus 8 on the left-hand side, and on my right-hand side, 2 squared is 4. So again, when I take the square root, the square and the radical cancel. Now, I just solve the equation. This is a linear equation, so it's pretty simple to solve. I isolate x, I add 8 to both sides, I divide by 4, I get x equals 3. Now, we must check. I like to check in the calculator. So if I'm going to check in the calculator, I'm going to do it by storing, which we've already talked about. So I'm going to store 3 as x, so I'm going to hit 3. And the store button, remember the store button is above the on button, x. I'm going to type in the left-hand side, 5 radical 4x minus 8. To get out of the radical, I hit the right cursor, plus 2. 12, the right-hand side is 12, so this one does check. And that's your answer. Now, you don't have to do the check in the calculator. You can do it by hand, but I like to just do it in the calculator just so I can get my check done and move on. So again, I isolated the radical. I subtracted 2, and then I divided by 5 to get the radical by itself. Once I had the radical by itself, I squared both sides because the square and the radical cancel. From there, I solved the equation, and I checked. Now, the cubed roots, they don't really come up much, but I figured I might as well do one of them. I think I put 2 of them on here. So, it's the same concept. We're going to start by isolating the radical. Subtract 5 from both sides. I get the cubed root of x plus 5 equals 2. And now, to get rid of a cubed root, well, to get rid of a square root, we square both sides. To get rid of the cubed root, we cube both sides. The cube and the radical cancel. I'm left with x plus 5. 2 cubed is 8. And then I solve the equation from there. I want to check. So I'm going to store, 3 again. So I already stored 3, so I'm going to type in the left-hand side, cubed root. To type in cubed root, it's math 4. And that equals 7, so it checks, so we're good. Cubed root's not really super important. In fact, I feel like I could probably take these examples out. They don't come up on the regents, but I figured I'd throw them in just in case. Alright, let's jump ahead to number 4. let's jump right ahead to number 9. And what I would have done, I would pause it at this point. I would go back and do a couple of the more basic examples before we move on to number 9. But I don't feel the need to go over any more of the basic ones. We're going to start going over the ones that get a little more complicated. So, number 9, my first step is to isolate the radical. Is the radical by itself? No. I need to subtract 1 from both sides. So on the left-hand side, x minus 1 is x minus 1. On my right-hand side, I have rad x plus 5. Great. Now that the radical is isolated, to get rid of it, I square both sides. On my right-hand side, the square and the radical cancel. I'm left with x plus 5. On my left-hand side, I have x minus 1 squared. Well, we've seen this quite a bit this year. X minus 1 squared means x minus 1 times x minus 1. So we're going to do our box. Now again, we learned square binomial theorem. If you use square binomial theorem, you don't have to do the box. But most of you don't use square binomial theorem, so we'll just do it with the box. So I multiply each of them. I then combine like terms. And I replace it with the x squared minus 2x plus 1. Mr. X squared, what does he want to do? He wants to party. Can he party right now? Nope. I gotta bring the x and the 5 over. I get x squared minus 3x minus 4 equals 0. From there, I factor. First sign comes down. Negative and a negative is a positive. What multiplies to 4 subtracts to 3. 4 and 1. Set each factor equal to 0. Solve each of them for x. I get x equals 4 and x equals negative 1. So within the radical equation, it's very possible you're going to have a quadratic equation in Mr. X squared. So once you see that x squared, you follow your x squared story. Now I have to check. So again, I'm going to check in the calculator because I find it to be the most efficient way to do that. I'm going to start by checking 4. So I'm going to store 4 as x. I'm going to check it in the original equation. So my left-hand side is just x. My right-hand side is 1 plus radical x plus 5. Basically, I need them to match up. Do they match up? Yes. So 4 is good. Now for 1, I'm going to store 1 as x. And I can just copy and paste. My left-hand side was just x. My right-hand side was 1 plus rad x plus 5. Those do not match up. So what that means is we cross it out, we write reject. That's your answer. Negative 1 is what's called an extraneous solution. It's a solution that was created, but it's not an actual solution to the question. So an extraneous solution, again, is basically an answer that you get through correct work, but that doesn't check. It is not an answer. The answer to the problem is just. Number 10 is pretty much the same exact thing. Let's go through it together, but we'll go through it slow. So, first step is to isolate the radical. Is the radical isolated? No. I want you to isolate the radical right now on your own. That should take about 10 seconds. Add x, x plus 3 equals rad x plus 5. Now, is the radical isolated? Yes. To get rid of the radical, we square both sides. So I want to see that step. I'll give you about 30 seconds to do that. Square both sides. Square, 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 and the radical cancel. X plus 5 is left on my right-hand side. My left-hand side is x plus 3 squared. So now I have to do x plus 3 squared. So to do a binomial squared, I'm doing x plus 3 times itself. And to do that, I'm doing my box. I'll give you a minute or so to do that on your own. If you need more time, pause it. Okay. X squared plus 3x plus 3x plus 9 is x squared plus 6x plus 9. So I replace this with x squared plus 6x plus 9. Now I solve the equation. It's Mr. X squared. He wants to party. Can he party right now? No. All his friends have to come over. So I want you to do this step right now on your own. I'll give you about a minute and a half to do that. I'll probably give you less. I'll just give you a few seconds, and then I'll say you can pause it for more time. But I want you to, from here, solve the equation, follow your Mr. X squared story. Okay, you can pause it. Give me more time. We're going to bring everything to one side. X squared plus 5x plus 4 equals 0. I'm going to factor. What multiplies to 4? It adds to 5. 4 and 1. Set each factor equal to 0. And I get x equals negative 4, x equals negative 1. This lesson conceptually is not very difficult. You're just isolating the radical, squaring both sides, but it incorporates a lot of algebra skills. So if you have strong algebra skills from earlier this year, this lesson should be good. If you don't have strong algebra skills from earlier this year, well, then this is going to be rough. You're going to have to kind of go back and make sure you know how to do box method. Make sure you know how to solve a quadratic equation. Make sure you know how to factor. Now that I have my answers, I must check. So I'm going to start with negative 4. Negative 4, store as x. I go back to the original problem. My left-hand side is 3. I don't think I need to type that in. So basically, I need this to be equal to 3. For them to be equal, is this equal to 3? Nope. So negative 4, I reject. It's an extraneous solution. Now I'm going to check negative 1. And I can just copy and paste that. Again, the left-hand side is 3, and the right-hand side is 3, so that one checks. And your only answer is x equals negative 1. That's pretty much it. The rest of them are all pretty much the same. For 17, you know what, for 16 and 17, I feel like part of me wants to say, especially for 16, part of me wants to say just don't do it. But here's what I'm going to say. What I would do for number 16 is a multiple choice strategy, which is just substituting each potential answer in and seeing what works. So why not? Let's talk about that now. I was going to talk about that this quarter anyway. You know what? Nah, I'll save it for another time. I wouldn't do number 16. It gets real nasty doing it by hand, so I would just say cross it out. And that's it. So, practice this to solve radical equations. Isolate the radical by adding or subtracting first, dividing last. Then you're squaring both sides. Then you're solving the equation. Within this step, you might have to do your Mr. X squared. Or you might not. Depends on how the equation works out. And then once you get your answer or answers, you have to check to make sure that they're equal. And if it doesn't check out, just cross it out and write reject. Your classwork/homework is to finish solving radical equations. And I hope everybody enjoys the rest of their day.